17 on 2.3. All right, 17 on 2.3. So it says reasoning. I wonder, says, complete the following statement. Describe the reasoning that supports your answer. So it says the transitive property of falling dominoes. If domino A causes domino B to fall, and domino B causes domino C to fall, then domino A causes. Now, remember the law of syllogism that says if we connect a whole bunch of things together, we can disregard all the middle stuff and say if A happens, then the very last thing is going to happen. So in this case, we have dominoes falling. We have A causes B to fall, B causes C to fall. That means A at the end of the day causes domino C to fall down. We can skip B. So if we go all the way to, M, A causes M to fall down because it takes A's movement and the connection of all of them to drop M. So it causes C to fall. Now describe the reasoning that supports your answer. That's what I was kind of talking about, that A causes B, B causes C, C causes D, D causes whatever. So A caused all of it. A can be tracked to all of them. And a good reason for that is the law of syllogism. Because the law of syllogism says if things connect up, then the first part causes the last part to happen as well. Does that at least make sense? Give you some stuff to write down? Cool. All right, Santiago, did you have your hand? Okay. Sorry, I stole it from you. All right, other questions from last night's homework? There should be some. 16? Oh, right here. Mm-hmm. All right, so this is transitive property of congruence. If angle XYZ equals AOB and AOB equals WYT, just like this one, the domino one, that if A goes to B and B goes to C, then A goes to C. What we can do is AOB links these two statements together. It's just a link between the two. So that means if we start at angle XYZ, we can conclude with it's going to straight up just equal WYT. We can get rid of the middleman. Basically, we're just getting rid of the middleman that joined the two things together. And so we're saying that those two, the first and last thing, are also joined up together. Yeah, Oliver.
19, I had a question about the A.
Yeah, let's bring up 19 real quick. I don't think that's going to be the whole picture. 19, I'm missing a little bit of the picture, but that's okay. Is that one 19?
Yeah, I just need
A. Okay, A. So what I'm looking at is we have two segments being added together to make a bigger segment. So we did that in chapter 1. We just we talked about it, but we didn't really necessarily remember it. When I have a segment added to another segment to make a whole segment, that's called the segment addition postulate. The segment addition postulate allows segments to be added together. Just like the angle addition postulate allows angles to be added together. So this one would be the segment addition postulate. Segment addition postulate. If it was two angles being added, it'd be the angle addition postulate. And those are in your postulate sheets. We just got to be aware of where they are. If you read through the postulate section, it does do the angle and segment addition postulate. We just have to be, that's why it's a good idea to just, can everyone listen to me really quick? Make sure you're practicing just looking through those sheets and knowing where things are. It'll make your life so much easier. Yeah?
So why isn't A given?
Why isn't A given? Because A was already given up here. So they already gave you a fact. This was, I have to do something with that fact. So it had a starting point given, and it told you what you had to prove, basically. And we'll talk more about that today. Like I said, we were taking kind of a leap of faith yesterday. Now we're going to concretely say, if this, then we do this. We just kind of were playing loose and goose with the rules. Today we'll signify those rules a little bit better. All right, other questions from the homework? There should be some. Going once. Going twice. I told you that was the big one that connects to all the other stuff. Okay, hope you're not lying to me and you got this stuff. All right. Today we're going to talk about the concrete, how to prove something. We're going to straight up call these proofs, and we're going to show how we're going to prove them. Make sure all electronic devices are put away. put away because it seems to be a distraction. Okay, so proofwriting. We're going to do something called two-column proofwriting. Two-column proofwriting is basically you create a T-chart or you create boxes. And you create two columns like we did yesterday, where one side has your steps, the other side has your reasonings. This is called a T-chart or a two-column proof. There are other ones that we're not going to do. There's flowchart proofs. There are paragraph proofs. But in this class, we're just going to focus on the two-column proofs, which will look like this. So note here. Now, this gets to Santiago's question. What I want to point out here is you're going to be given something. It's actually going to be your job to rewrite what was given to you. So the first statement is usually, and I'll almost say almost always, the given. So look at this first step. This first step is actually copy and paste and write given. What this means to you is if you pay attention right now to what I said, even if you don't know how to write proofs on the test, you'll be able to at least do the first step. You know it's copy the given and write given next to it. And then we work through it. We use logic to work our way through it, and we end up with what we need to prove. So all of these need to start with a given and end what needs to be proven. Now, I'm going to point something out here. Sometimes it says prove, sometimes it says show. It means the same thing. Show and prove mean the exact same thing. Give me something, prove something. Give me something, show that it's true. Now, on the right side, we have to use a bunch of reasons. Your reasons are going to come from that packet that we have. Those will include postulates. They'll include definitions. Hello. They will include theorems. So basically anything from that theorem postulate sheet that you have can be all things that support your reasoning, minus the given. The given's just given. All right, so left side, your steps. Right side's why you can write that step. Don't forget to write down given, otherwise all your steps are going to be in the wrong order. Now that we have that going for us, now let's reintroduce what we did yesterday. Yesterday I just said kind of you do your steps and you do your reasoning next to it. Now we're calling them straight up proofs. So here, I'm going to be given something. Your first step is to rewrite that. I already did that for you. Now we need to write the reason. Now, do you see how this is numbered 1? It's not just because Mr. Pabian's nice and sometimes number stuff. Your proofs need to be numbered. So if number 1 is this, we have to put 1 given here. You need to have both of those numbers. So if this says 1, this has to say 1 as well. So we always have those like little bit of rules that can twist people up. Do it now when it's easy, so when it's hard, you don't forget about it. So 1 given. Step 2, we work on the left-hand side. Left-hand side is all our work. Right-hand side is our reason. Can someone raise your hand and tell me what I should probably do between step 1 and step 2 to start solving for this? Yeah. Multiply this -4 into that 6 and that 2. What was that called? Distributive property. So we're going to now have -24x minus 8 equals 64. And that will be our distributive property. Now remember, distributive property, we don't have to put the property of equality. We don't need to put PO. PO is just for addition, subtraction, division, and multiplication. So this is just a distributive property. Can someone else tell me what my next step is? Owen?
You add 8 to the other side?
I add 8 to the other side. Now, don't, yep. Well, yeah. Thank you. Thank you for saying that. You can write it there. All right, don't feel afraid to write stuff in between here. Even though it's written out for you, if you need to write the stuff in between to help you, because for me, I'm just like, I need to see I added 8 to both sides. I add 8 to both sides, and so I have -24x equals 72, and I do like the POE because we are adding, but we should add the POE to get it 100% correct what we're doing. We're not just adding, We're adding to both sides, which is the property of equality. Adding just says I can add two numbers together. Adding property of equality says I can add it to both sides. What do I do next? Alejandro? I'm going to divide POE. I'm going to use that division property of equality.
You have to put POE at the end.
You do. You have to. So Owen, and he just said the perfect thing. Am I doing it to both sides?
Yes.
Yes, so that means I have to put POE after it. If I just put division, it means I just divided one side by something. POE lets me do it to both sides. So we're now going to have x equals a -3, and that's going to be division property of equality. Stop right now, because this is what I see all the time. Look at yours. Does yours have these numbers on it? I said to put them on it, but people forget. Does yours have numbers on it? If it doesn't, add them right now. Know that that's really important for you to get your points across, that we use everything numbered. 1 goes to 1, 2 goes to 2, 3 goes to 3. And the reason why we do that is because sometimes we put more than one thing in there if it's using the same property. So the given might be like 5 things. So I'll write a whole bunch of things in here, but I know it just goes to the one given over here. So they must be numbered. Elmer, did you have a question?
If you don't number it on the quiz,
You don't have it correct. I mean, you'll get points, right? But I can go, minus half point. They start adding up if you keep forgetting. Easy thing is, don't forget it. The whole point is I want you to be able to clearly show Ty what yours looks like, and he should know exactly where things match up. Or not Ty, I guess. But, all right. So that's the big thing, that we have those things. Then just remember, we have all of these properties. We're going through this really quick again, our packet. Don't forget about your definitions. One of them that catches people up is this congruence one. I'm actually going to put a star by that. We typically know it, but we forget when to use it. Now, it won't be so important today, but I'm going to keep highlighting things for us to keep track of. If you remember back to our second day of school, I talked about using an equal sign and a congruent symbol. I said if we're talking about the shape, so here we have, can we all look up here? We all look kind of, or on your sheet, one of the two. You should have your sheet out, because you shouldn't have to look up here. You should have your sheet to learn how to use it. Now, congruence. Congruence allows me to go between equal signs and congruent symbols. So in this case, see how we have segment AB is congruent to segment CD? If I ever had to say that their measures are equal, I need to use the law of congruence, or the congruence property, to say that means the same thing. So once again, if I say segment AB is congruent to segment BC, and I need to then say, hey, their lengths are the same, we have to use congruence to get between those two statements. They mean slightly different things. Yes? That will also work for angles. If I say angle A is congruent to angle B, but I want to talk about their measures, I then have to use congruence to say that means measure A equals measure B. So if you ever have to get between measures and congruence, congruence, we're going to use the definition of congruence for those. Another one you might want to look at is the linear pair that's hidden right there. All the linear pair says is two angles that are adjacent to form a line. Does that say anything about 180 degrees or supplementary? No. So the definition just says that if they form a straight line, they're a linear pair. What I want you to do now is I want you to look at your theorems. I know I didn't put it on here. Look at your theorems. Is there a theorem that talks about supplementary, not supplementary, but linear pairs? What does that one say? Read it out. Not aloud, just read it to yourself right now. And I want you to think about how that's different than the definition. So right now we're looking at the linear pair theorem, and we're asking ourselves, how is that different? From the definition. I'm looking for one word, or describe it to me. Who thinks they know the difference between the definition of linear pair and the theorem of linear pairs? by them. All right. Quick warm-up review. We're going to be given something, and we need to say, how do we do the next step? So it says AM is congruent to MB. We have a little drawing back there. There must be a reason that M is the midpoint of AB. There must be something in that packet that talks about midpoints, particularly that a midpoint creates two congruent segments. Is there anything in our packet that says that? Something about midpoints creating two congruent segments. I'm going to give everyone a chance to look up. We're looking for midpoints. All right, who thinks they found it? I don't need to get an answer. Who thinks they found it? Who is still looking through their packet? And we're just looking for the word midpoint right now. Do we all get a chance to look through our packets? All right. Now, you probably found midpoint in two places. The midpoint postulate, and you should have found the definition midpoint. Let's see which one matches this situation. So I'm saying, okay, a midpoint creates two congruent segments. Let's read the midpoint postulate together. Exactly one midpoint can be constructed on a segment. Does that say anything about it creating two congruent segments? Don't read between the lines. It either says it or it doesn't say it. Does it say anything about congruent segments? No. Let's go to the definition of midpoint. Definition of midpoint, a point that divides a segment into two equal segments. Does that talk at all about creating two equal segments? This is the definition of midpoint. You almost never use the midpoint postulate. You could almost put like a little X through it, like I wouldn't scribble it out or anything, but maybe put a little X by it, say I don't use this very often. Most of the time we're going to use the definition of a midpoint. Yeah.
Do you put two layers or like something?
Yes, we probably should. Thank you. Let's put our ones and twos. So I told you sometimes you are given two givens. Now, a lot of times I would just put a 1 by both. We'll get to that later. But right now we have two givens. I'm given that angle ABC is equal to DEF. DEF is equal to RST. This is one we need to get in the habit of realizing right away. This is something linked to something. That thing links to the last thing. Not reflexive. Transitive. Transitive says if A equals B and B equals C, then A equals C. That is right in our thing here. Where did I miss it? Did I miss it? Oh, no, you have it in your other part. Oh, you have it here. Right here on your algebra things. Transitive property, like I said, I think of it as a transitive property. It links a lot of things together. I have things being linked together. I have A equals B, B equals C, so A equals C. This is the transitive property. You have to start seeing transitive property quickly. That one's going to happen a lot. That's why I told you to box it in star or something. We're going to use it a lot. Transitive property gets used a lot. All right, our next thing is if angle F equals angle T and angle T equals angle A, then measure of angle F equals measure of angle A. What is it? What is it? What is it? What is it? It is the transitive property. It is F is linked to T, T is linked to A, so F can go straight to A. It's like that domino thing. So we have, once again, the transitive property. Think it's weird that I put it back to back? Probably. Probably important. Okay, our next one, see how we have like A to B to C? That means they're all in a straight line. So you're given a straight line that includes A, B, and C. They're saying that AB plus BC equals AC. So what they're saying is, well, if I take a segment, add it to another segment, it creates our entire line. Is there something in our packet, don't just shout it out, is there something in our packet that says something about segments like that? Elmer?
Segment addition function?
The segment addition postulate.
Wouldn't that look the same instead of it's taking one thing plus the other thing and that equals the whole thing?
It's not linking them together, though. So look at the difference. The difference here is F is linked to T. T is linked to A, so I can link F to T. This is just saying one part plus another part equals a total part. They're not linking to like a third thing. What you could do, so let's see if this helps at all. Let's say I have a segment addition equals the entire length. And then I tell you AC equals DF. So if I said this entire length equals some length D to F, that would link B plus BC to DF. So it has to have that second link in there. Okay, let's keep plugging through. So it says AC is a straight line. Angle 1 and angle 2 are supplementary. Now, they create a straight line, so they create a linear pair, correct? Does the definition of linear pair say that they're supplementary? Look at your definition of linear pair if you're not sure. Does the definition of linear pair say that they're supplementary? No. So we can't use the definition of linear pair. I'm looking for something that says linear pair and supplementary. It's got to say both things. It has to say linear pair and supplementary.
Linear pair postulate?
Joseph?
Linear pair theorem?
It's going to be the theorem. The theorem says, so if you look at the theorem, it will say the word supplementary. You're looking for the exact word supplementary. Yes? Yes. So we're going to use the theorem. The supplementary, no, not supplementary, linear pair theorem.
Even if it says 180 degrees, you're looking for the word supplementary.
I'm looking for the word supplementary. So if it said angle 1 plus angle 2 equals 180, we would look for that one, because it says exactly 180.
Okay.
It has to say the same wordage. We could change it, so I could say supplementary means 180, so we could go further and try to push it into there, but you have to find that exact wordage. That's what makes proofs hard sometimes. All right, our last one says, our last one says that it equals 180. It says measure of angle 1 plus measure of angle 2 equals 180. Does the definition of a linear pair say they equal 180? No. Does the theorem say they equal 180?
No.
Does it say exactly 180 or does it say supplementary? It says supplementary. There's one that says exactly 180. Ty?
The postulate.
The postulate. So this would be the linear pair postulate.
Put one in front of the
I'm sorry, what did you say?
put one in front of the given.
Yes, I should put one in front of the given. Thank you. Guys, this is important. Linear pair appears 3 times. It says 3 things that seem very close together but are different. One says what a linear pair is. The other one says that they equal 180. The last one says that they are supplementary. All 3 are in there because they all say different things. Pick up your head. Okay, let's do some mini proofs. Baby proofs. So we're supposed to draw the appropriate marks on the diagram. That's important to proofs, is drawing things on the diagram. Complete the conclusion by filling in the missing information. And then we're supposed to use one of our theorems, postulates, or definitions from our notes to fill in the reason. M is the midpoint of AB. You should put marks on the drawing. What mark should I put on there? Thanks, Ty, for throwing your voice to everyone. We're going to put tick marks. Tick marks saying that those 2 things are congruent. So my conclusion is that BM is congruent to MA or AM, doesn't matter. MA, I'll put that. We have a midpoint postulate and a midpoint definition. Which one says it creates two congruent? Don't shout out the answer. One of them says it creates two congruent segments. The other one says you can put a midpoint on there. One of them I said we're not going to use. One of them I said we should use all the time, basically with midpoint. Which one should I use, the postulate or the definition? I'm going to use the definition. Thank you. Definition of midpoint. The definition says it creates two congruent segments. B is collinear between A and C, so that just means it's between. We can't really put any marks on there. Nothing's congruent. All it says is it's between there. It's already drawn for us. But then it says AB plus something equals AC. Raise your hand and tell me what we're filling in that blank for. Yeah. Yeah, either one. It'll be the line segment postulate. Not quite. You're close. It's just called the segment addition postulate. You had it. We just got to be clear that we put the right thing down. Segment addition postulate. Okay, so the reason stolen, that's the hard one. What are we going to fill in that blank, though? Yeah, Alejandro. We're going to put BC. The segment addition postulate says I can take two segments, put them together, and they equal the whole big segment. Let's continue on. AB intersects CD at O. Does it say bisect? No. If it said bisect, I have to put tick marks on there, but it doesn't say bisect, it just says intersect, so we can't put those on there. But then it says we can say AOC equals what angle? This one's tricky. We haven't done this one yet. AOC equals what angle? Oliver? DOB. I agree with that. Someone besides Oliver, how did Oliver know that AOC is congruent to DOB?
Because
No. We have to add something to it. I'll just call it vert angles. We have to put something on that. We can't just put vertical angles. Does anyone know what I'm attaching to it? You're on the right side. What am I adding to it? Not just vertical angle. I have to say it comes from a certain part of this packet. Yep. Theorem. Vertical angle theorem. It's got to be the theorem. You can't just say there's vertical angles. You have to say we're using the theorem. The vertical angle theorem says that vertical angles are in fact congruent if they're across from each other. Last one, angle 1 and angle 2 form a linear pair. Can't put any marks on there because they're not congruent. It says angle 1 and angle 2 are. Now, it doesn't say equal to, it says they are, so I should describe them as something. What can I describe angle 1 and angle 2 as? I already know they're a linear pair. Santiago, I could say they're supplementary. We should be at the point that we know linear pair shows up 3 times. There's a definition, there's a postulate, there's a theorem. Which one of those says that they are supplementary?
the theorem.
Hang on. Which one says that they're supplementary? Joseph, stand. It's going to be the theorem. The definition says they basically exist. The postulate says they equal 180. This one says they're supplementary, so there's going to be the theorem. Linear pair theorem. Are we good on those? Okay, then we will continue on. Let's increase the rigor a little bit. So now we're going to have part of a proof written for us. Now we should have numbers here, so let's go ahead and put numbers next to all of those. They didn't quite give us room, but we can cram them in there. So these are partially filled in proofs. We still have to know what's going on. You can't just make stuff up along the way. We have to understand kind of the flow of things. The first thing we should get right. What goes in that first blank box? Anyone shout it out? Given. Given goes in that first box. Boom. All right, now let's look up here. So it says given. Angle 1 equals 50. We should probably go to the picture and write 50 degrees by angle 1 so I can see in the picture. Angle 2 equals, angle 2 equals 130. Angle 3 equals 50. We're supposed to prove that 2 and 3 are supplementary. So 2 and 3 need to be supplementary. So we write all of our given down. How do we know angle 1 is equal to angle 3? Yeah. I put transitive, but how does that make sense? Yeah.
Vertical angle theorem.
Not the vertical angle because they're apart from each other. I did say it's transitive. How does transitive make sense for angle 1 equals angle 3? Can someone explain that to me? Yeah.
Because it's all adding up to one.
Not because it's all adding. I'm just saying, how do I have angle 1 equals angle 3 and I said transitive property? What does the transitive property say? Let's keep our head up or we're standing.
Oh, because angle 1 is 50, angle 2 is 50, angle 3 is 50, 50 is 50.
Perfect. The 50 is what joins them together, right? So angle 1 equals 50, 50 equals angle 3, so transitive property lets us say that those two things are equal. That's important. All right, so that means angle 1 is congruent to angle 3. Thank you. This is the one that I talked about. Yeah. If you ever go from measure to congruence, you have to use the definition of congruence. Okay, measure of angle 1 plus measure of angle 2 equals what? Equals what? 180? Measure of angle 1 plus measure of angle 2 equals 180 because we now know that angle 1 is 50, angle 2 is 130. Cool. Angle 1 and angle 2 are what then? If they equal 180, what's a word I can put in place of 180? I can call they're supplementary. Why can I say they're supplementary? Is there something in our packet that says supplementary angles equal 180? If you're just sitting there looking vacant across the room, you're not doing your job. You should be looking in your packet for something that says, oh, angles that are supplementary equal 180. Yeah.
Linear pair theorems.
Linear pair theorem. I didn't say they're a linear pair. I just said they're supplementary.
Oh.
I'm looking for something that says supplementary are angles that add to 180. Julian?
Definition of supplementary angle.
Definition of supplementary angle. All right, the last thing says angle 2 and angle 3 are supplementary. What I'm going to notice is the only difference between these two steps is 1 got replaced with 3. What allows me to replace things in math? Instead of using replacement, I use substitution. This would be substitution. Or, I'm going to put substitution down here. Let's just leave it as substitution. That's perfect for that one.
Does it matter if you put like definition of substitution?
It's not it is what substitution. I get it, but just put substitution.
Okay.
Because it's not. We're not using the definition. It is the action that it provides.
Okay.
Kind of like when I say adding, I'm not saying the definition of adding. I'm actually adding. It's the verb.
Okay.
All right, so that is our first kind of mini proof.